So, just a little bit of review. We left off with the angle sum and angle difference formulas. Which I wrote wrong on the test anyway, so I don't really know why. You trust me to review this. We had a formula for adding two angles inside of a cosine. If you remember the way that that works, you do cosine of the first, cosine of the second, minus sine of the first, sine of the second. Actually, this reminds me of something that I kind of want to talk about. Let me write the other one down. So, there was cosine of a difference, which was the same thing except you change the sign, cosine alpha, cosine beta, plus sine alpha, sine beta. And then there was the sine formulas, which were the ones I messed up. So sine alpha plus beta is sine alpha cos beta plus sine beta cos alpha. Okay, so what I want to do quickly is go over the identity, actually, now that I think about it. There weren't any problems I thought that everybody really screwed up on, but the identity, the number 8 was closest. Number 8 I gave a lot of -3s on, so let me go through it quickly. It said that tan squared x minus tan squared y is supposed to equal sine x plus y, sine x minus y, over cos squared x, cos squared y. So, to verify this identity, where do you want to start? Left or right? I would start on the right because it's more complicated. There's more stuff you can do there. So I would come over here and say, well, sine x plus y, sine x minus y, over cos squared x, cos squared y, equals, and then on the top you can actually write out the formulas for these. Now, the reason I'm going over this is because I saw a lot of people write this for their next step. Sine x plus y equals sine x plus sine y. It made me so sad. Right? It's just, you can't just distribute the sign. Right? If you remember anything at all from this, if you have sine with a plus inside or cosine with a plus inside, there's a formula. If you don't remember the formula, that's fine, I don't care. Nobody does. Okay? But just remember, you have to use a formula. You can't just distribute it like this. Okay? This is making angels cry. So, instead, you apply this formula right here. You do sine x cos y plus sine y cos x. Sine of alpha plus beta. This is alpha, this is beta. So alpha, beta, alpha. So the x and y switch. So there's the sine addition formula applied to the first factor. And then you apply the other formula to the second factor. So you do sine x cos y. But then this sign is going to change because it's now a subtraction. So it'll be minus sine y cos x. All of this over. So that's how you were, that's one good way to start. This will get you where you want to be, even though it's super ugly. Because what you might notice pretty quickly is you have kind of a difference of squares formula going on here. Because these two factors are exactly the same except with the opposite signs in the middle. So what's going to happen when you actually FOIL this out, you have to take sine x cos y times sine x cos y, which is what? Sine squared x cos squared y. And you do this guy times this guy. Sine times sine, sine squared, cos times cos, cos squared. Then the middle terms are going to cancel, right? When you do sine x cos y times sine y cos x, and then you do this guy times this guy, you'll get canceling. That's how the difference of squares works. So really all you need to do is move on to these two. So minus sine squared y cos squared x. Because the middle terms drop out, you can just multiply the ends. The outside means. And then you have to split it up, right? Since you're trying to get the tangent, you're going to want to, you have a tangent minus a tangent. So you're going to want to split this fraction into two separate fractions. So sine squared x cos squared y over cos squared x cos squared y minus sine squared y cos squared x over the same thing. Remember, you can split a fraction up. You just divide the denominator into both terms. So you put the cos squared x cos squared y underneath here as well. Then cos squared y and cos squared y cancel. Cos squared x and cos squared x cancel. So what are you left with? Sine squared over cosine squared? Tangent squared. And then sine squared over cosine squared? Tangent squared of y. And then you can put the check. It's a lot of checks. It's a lot of checks. I didn't see a lot of proof of the check. So, hopefully you got some credit on that, but if you didn't, then this is what you're supposed to do. I wanted to review these formulas because we're going to use one of them right now, and kind of the best way that came to me to review these was to do this problem.